Okay, I think I may have. Okay, I'll come to you. I may have something for you because that's one of the problems that I'll be solving through this framework. Okay, good. Go ahead.
I think Sonnet's been pretty cool. Like I've been able to build React apps without coding that much before, so I kind of want to build a framework to try to automate and like augment my involvement further.
Okay, sounds good. Anyone else? Go ahead.
I'm curious about how you structure tool use, like if what tricks you use to give it your input, how you extract output from it, how you feed that into other parts of it, preventing prompt injection, that sort of thing.
Okay, got it. Anything else? Going once, going twice, going thrice. I'm not going to answer any question outside of whatever I just heard. This is our contract. Let's begin. Okay. So we just kind of walked through it. I gave like a brief introduction. So I think as per agenda, I've kind of covered the generative AI part of it. So we'll go with the, I think kind of, so let me just go through it. How many people here have heard about digital twin? Okay, let me ask from you, like, what do you mean by digital twin?
It is a semi-autonomous instance that you have fed with some data, maybe your own personal data, that can act on your behalf.
Got it. Okay, I saw some show of hands. Go ahead.
Yeah, I mean, I think of it as building a model around something in the real world that you can run simulations through, so you don't have to run those simulations on the actual environment.
Got it. Got it. Should I repeat? Is everyone able to hear what they are saying, or I can repeat for others' purposes? Should I repeat, or were you able to hear it?
It's good practice to repeat.
Okay, good. So I'll repeat. So basically, what my friend here said was being able to create a simulation of real world that kind of mimics possibly yourself is considered as digital twin. And I'm improvising also as I speak, so please don't hold me to that. And I saw other shows of hands somewhere here. Who else wants to answer? What is a digital twin? Go ahead.
Simply, it's just a digital representation of something that exists in the real world.
Okay, exactly. Digital representation. What else? Anyone else? No one. Okay, great. So that's what digital twin is, and I'll show up in this presentation today. I'll establish another kind of a digital twin as it represents within the generative AI framework. So that's we are. How many people have heard the word SNMP? No one. Any guesses? Go ahead. No. It has nothing to do with generative AI, by the way. Now take a guess. What is SNMP? Anyone?
Synaptic neural mapping pathway?
No.
Oh, fuck.
Don't worry, it's fine. Like, okay, so let me ask, how many people here have had a background in networking? Ever? You had networking? So what is SNMP?
I have no idea. Otherwise, I would have answered.
How many people know, yeah, go ahead.
I did this a long time ago, but I think it's a protocol.
Yeah, it is a protocol.
Networking protocol.
Yes, it is a networking
protocol.
simple
Network
network
manager.
management protocol. That's right. So essentially, whenever we create a new innovation, right? Nothing is new in this world. It's always about we build those innovations on the ideas that already exist, right? And that's exactly what I have done. But I'm calling it as an innovation because in this form, it was not present earlier. That's all it is, right? So I have used some of the ideas of digital twin. Of course, I did not create generative AI. It already exists. Neither did I make my own model. They already exist, right? So I'm not trying to reinvent the same wheel, but what I'm doing is some of these things already exist. I'm trying to bring them together into a new concept that can actually solve certain specific problems, which is what we are going to illustrate today. So the main goal of today's presentation would be how do you solve complex problems through generative AI? So in industry and enterprises, I have seen a lot of times myself, I have had customers in the e-commerce and fintech domains. When in 2 years back, when this chat GPT, generative AI became very, very popular, everyone started building their bots, right? So they said, okay, we are going to build a bot that can quickly answer questions, etc. So there was a lot of interest in start of 2023, and a lot of projects started, etc. But by the time we started coming towards the end of 2023, and we are already in 2024, that initial interest started kind of tapering down over. The reason for that is because a lot of investments were being made by the companies thinking that they can do a lot of things, but soon enough it became very clear that just asking question answers doesn't actually technically solve any use case for the companies actually. So you already had bots even 10 years back as well. You had cognitive Azure framework from like Microsoft, Cortana, I think that's what it is called. Then you had bot framework from Meta, from Google, and most of the time they were used in call centers to like answer queries and things along those lines. And how many of you have actually talked to a bot over like a phone or an IVR machine? And did you try to like scratch your like pull out your hair? Like how many of you have had this experience when you are connected to a bot and it will keep asking you some random? Yeah, go ahead.
Yeah, no, it's kind of like the paranoia of the digital era these days because you get in a conversation with somebody, they say something a little bit weird, all of a sudden it's like, just tell me you're a real person. I'm not a robot. Why would you think that? And it gets to the point where I randomly ask people to solve random Python problems just to see if they do it, because if they do, then they're very clearly a bot.
I thought you would say if they don't do, then they will not. Yeah, you're right. But yeah, so I mean, I myself have been to so many, like when I call like a bank or like my telco company or my internet service provider, and more often than not, they'll connect me to a bot. And even though I know what my problem is, and I know this bot can solve that problem, that's why I'm calling them in the first place. They waste your time, like click this, did I solve your question? And then it keeps asking, did I answer your question, answer your question? And you have to say, hell no, you never answered any of my question. Please connect me to an agent so that I can talk to them. Go ahead.
Swearing works.
Yeah.
A lot of the old systems are hard coded so that if you start swearing a lot, then it immediately escalates you to real people.
Right. So, anyone else has examples of their like frustrations with dealing with a bot or like an agent, whether through chat or over online and things like that? Anyone has a story to share or any example? Anyone? No. Okay. Go ahead.
So one particular issue I've had, and I'm hoping you can actually help us address this, is defining reward goals for agentic models. Because if you have, let's say you have code and it says, hey, display this image as a circle and the image is a square. And in Flutter, my framework, it would say, oh no, this is an error. This is a giant red block. And then if you ask AI, fix this red block, it can mean that in one of two ways. It can mean, okay, read this code, semantically understand what you're trying to do in picture to the whole website, and create a circle avatar, or delete the code, and then there's no more error code.
Yeah, that could also be a possibility.
Yeah.
So great. So this is what we are going to basically through some examples, and this is great because the more question and challenges that you bring, I can incorporate it part of some of the protocol framework that I'm going to show today. That how you can incorporate that to basically solve complex problems in a variety of domains actually. So it is domain independent. So what I'm going to present today is kind of something similar to like people here have heard about Hadoop. I think many people would have heard, right? Like a decade back, like Yahoo came out with the framework. Of course, Google wrote the initial paper. I happened to be at that point of time at Yahoo, so I used Hadoop at that time. So what I'm going to present today is something similar on those lines, actually. So it is less generative AI because I'm going to reuse some of the things that already exist in generative AI. But how do you make that basically all these bots communicate with each other? That is why the reference of SNMP, Simple Network Management Protocol, like in a network topology, how these agents can basically communicate with each other, how they can divide the work between each other, and how they can accomplish a complicated task. That's all the crux of this presentation would be today. So moving forward, so we have already talked about ChatGPT. So pretty much most of the people have already used about we already discussed about it's mostly a Q&A framework, and that doesn't solve a lot of problems. Of course, it does solve, but not all of the problems. And some of the problems I want to give specifically in the example of is let's say I'm an e-commerce company, okay, and I have a huge fulfillment center where I have to stock a lot of products that customers are buying. So inventory forecasting, network optimization, route forecasting, route planning, like how do my trucks will go from here to there, etc. These are all complex problems. Do you think if I were to ask this question, okay, this is my inventory in my fulfillment center, please come out with a route plan for my truck so that I can have those items sent to customer locations in minimum amount of time while saving cost and the fuel cost. What do you think ChatGPT will give? Like, it won't be able to come out with a plan, right? Because it's too complicated a problem. It has so many sub problems inside it. That's the feeling of ChatGPT. It's very good if I had to ask the question, what is the capital of US? Who is the president of this? Like basic, like factual kind of questions. It can do well. Maybe I can ask some basic riddles and things like that also. It can still do well. But as we start going into more complex problems, it will totally kind of break down. And that's what we are here to basically solve. Like, how do we even try to do that? One of the problems that everyone would have seen is that we have heard this word hallucination quite a bit of times. How many people have heard here hallucinations? Anyone would like to define hallucination for the rest of the crowd as well? Anyone? You want to try?
Just when it makes things up. I was on a bourbon trip with some friends, and we asked ChatGPT for some very great eclectic places to go visit, and it sent us on a goose chase when we realized that it made up all kinds of places, locations, but there was no bourbon there. No bourbon.
Yeah.
Mm.
Absolutely, and this brings us a very interesting point. Why would a model like make up something that doesn't even exist? Does anyone has answers to it? Why would a model respond with something that didn't even exist? Like it's not even factual. Why do you think that happens? Anyone, go ahead.
It's optimized to make the reader of the response happy. And so if
Okay.
it generates content that seems reasonable, then the voter will be like, yeah, it's good.
Do you
And then
think in
they
this
haven't
case-
actually checked it at the time of voting.
That's good. So do you think he was happy after he did this?
No.
Great suggestions though. Raven's nest, all kinds of like real details that made it seem really believable.
Did you ask it for bourbon trip spots, or was it just trip spots?
Bourbon trip spot.
Okay, never mind. I acquiesce.
Yeah. So this could be one possible reason. What could be other reasons why it is showing something that doesn't even exist?
I mean, a lot of these GPT models are essentially autocomplete on steroids. So it's
Mhm.
intending to complete your prompt or respond to your prompt, and
Mhm.
whether the information is true, valid, or not is almost irrelevant to how it's inherently designed.
That's a very good point. So you are going towards statistics, right? So statistically, if something has occurred, so there are block of words, and there is most likely word that should come next. That's what it is trying to predict, right? Go ahead.
Well, it's also a problem of constraints, setting constraints.
Mhm.
I did not tell it to only give me real places.
Yeah, you just told whatever is possible.
Yeah, so it responded accurately, just didn't give me real places.
Right, right. Okay, that's a great point. So back in the day, right, in the search, so it is very similar to search problem if you think about it, right? So in search also you're looking for some kind of like answers. And why does search never give made up answers? Like anyone has, so there is a big difference between search and a question answer model. So in a question answer model, as we just saw from some of these examples, you can get an answer that's factually incorrect. It doesn't even exist, like the places or things like that, right? And we have seen it multiple times. But in a search, you can never, so you can get a wrong result, but it will not be something that is made up. You see what I'm saying? In search. Why do you think that's the case? Go ahead.
Because in search it's like a traditional indexing of the existing data, while on the ChatGPT it's actually generating new data as well.
Okay, that's a good point. Go ahead.
I was gonna say for your previous question, part of models is they're trained on a bunch of unstructured data, and part of the patterns it picks up on is creative thought and creative thinking for solving problems. And so that could be, its creative thinking could be it causing hallucination because it's just coming up with stuff.
Right, right. That's also a good point. I did see some other show of hands as well. Someone else wants to add, and then I'll complete my. Yeah, go ahead.
At some level, search, the link is your citation. And
Yes.
it has to exist.
Exactly. That's a very good point. So in search, that's a fundamental difference. So in a Q&A system such as ChatGPT, there is no explainability. In search, you always have explainability. Even if the answer is wrong, you can always point out because the link was wrong. Like, what can we do? We just surface the link we thought is the most likely answer, and in the link there will be the text and whatever, right? So search is just an intermediary where they basically bring in the information that it has indexed over several throughout the web, and based upon whatever your query was, it did a kind of a matching, and it showed you the most likely result. It can still be wrong because the matching may be wrong, but the result would be actually factual data because it was published in a link. In case of ChatGPT or LLM or generative models, even though they also use a lot of data, very similar to search throughout the internet that is available to build the model, but when the generation is done, you are never very sure exactly what it is going to generate next, because they have so many hidden layers of like neural networks and things like that that basically generate the model, and hence it's extremely difficult to even tell what was the source through which this was generated. Like some of the video models and audio models, you can like really tell, because you have seen the familiar music or familiar video, you know what might most likely be the source, but in a lot of text areas, etc., you'll not be able to tell that. So that's the kind of reason there is a difference. And I talked about some of the ills are like it's not good at logic and math, reasoning, problem solving, and we talked about hallucinations as well. So moving further, uh, these are some of the top points, like why in an enterprise setup a lot of these implementations of ChatGPT and a lot of these bot models have failed, and pretty much all large companies have actually started deploying these things, and even co-pilots and even things along like Dell AE, and even in video and audio spaces, a lot of these hallucinations happen even on the factual data, which for a novice would be very, very troublesome, because you would think that I can understand the data could be wrong, but it will be completely non-existing data that it is throwing out is completely unimaginable, right? That's one of the like flaws of like using these kind of LLM models. So how do we fix that? So I started thinking about it, a lot of research has gone into this. A lot of billions of dollars are being spent on this, and still, even after 2 years, even today, we have not got rid of hallucinations. So what is the solution? What can we do? Anyone here before we move on to this? Yeah, go ahead.
Ground the model in verifiable data and provide system prompts that prevent it from hallucinating.
How will you ground the model in the factual data?
RAG or
Okay.
context window limitations.
Okay. Fair enough.
Instructions.
Okay. Fair enough. Yeah, go ahead.
You could ask the same question of 5 different models,
Okay.
and then have the results evaluated by another model, and ask which is better.
That's a very good suggestion. Go ahead.
Continue his iteration chain to go through 5 times on the same model each time, so that way you can at least query like the same thing to get the best of each before you go to the next step, before you go to the next step, before you go to the next step.
Fair enough. So actually what I'm going to present is going to be similar to what you just said here. That's where the digital twin basically comes into the picture. So basically, the idea is that we can't get rid of hallucinations right away, right? And hence, we need somebody who is like your prime, who will continuously keep checking you. Like if I were a person and then I had a twin who would so whenever I speak something, and if they were to like stop me before I utter anything out of my mouth and try to see if it is grammatically correct, factually correct, there are no cuss words, etc., my speech would become so much better, right? That's what we are trying to do with generative AI as well, given that we know we cannot eliminate the hallucinations altogether. So what it will do is it is going to make it slightly better, but it will still not 100% cover the hallucination. That's the drawback that we need to know about it. But adding to that, we have also added a concept that we will create a network topology in such a fashion that a very complicated problem can now be solved through this framework, right? Again, with the caveat that we are not proposing that it is completely autonomous in the sense that you just send the problem, it will automatically create the twins and create the topology, and all the bots will talk with each other and finally give you the answer. Uh, Maybe one day we'll be able to reach there. At least as of this time, we are not there. Idea is only experts should be using this system. It is not meant for used by everyday people, at least at this point of time, right? Idea is if you are an expert in the field, you know what you really want, you understand prompting, then use the system, because as I said, we are not eliminating hallucination. We're just reducing their occurrence. That's all we're trying to do, right? So the output can still be wrong. It can be still non-factual, assuming that even though your twin actually approves it, saying that yeah, it is all good. Our hope is that like by having twin continuously checking what you're producing, the chances of hallucinations will continuously go down. And as each bot would only solve a specific use case, not the entire problem, because it will be divided into multiple bots which will talk with each other and do it. The chances and the likelihood of getting the optimal solution are much higher than giving everything to just one bot itself to solve for it. And let me go ahead. Um, so I'm introducing this generative AI protocol beyond the bots, and we call it as Autonomous Generative AI Communication Protocol, AGACP. That's what we are introducing, and we'll go through the architectural details of how this basically works. And the main use case here is that it is beyond just a simple question and answer, what we are all familiar with, the existing bots that are there. Uh, Idea is that basically the other friend did mention about rags, etc. So all those things are also being used in that. It's just that how we are going to use it to make it much more palatable for enterprise use cases is what we are going to present today here. So I'm very bad at drawings and things like that, so please don't judge me based upon the drawing that is going to show up later on. But mostly focus on the concept and the ideas that I'm trying to illustrate, and I'm here to speak. So I speak much better than what I draw. So just focus on me and don't focus too much on the diagram that I'm going to show you right now. So these are some of the tenets of this protocol. The idea is so the ideal use of this protocol is for complicated problems. That doesn't mean that you cannot work with smaller problems or small problems with this protocol, right? You can still use it. But the real meat of this protocol is where the problem is complicated, inventory forecasting, supply chain management, demand forecasting, recommendation system, things along those lines, right? You will be better be suited for this. So one is that as a simple network management protocol works, where each network element, so network element could be your router, your switches, and logical connections and things like that. They have to talk between each other, and they send a kind of a heartbeat between each other to tell that, oh, we are up and running, up and running. Something similar would be available in this as well, because there will be multiple bots in that topology who are communicating with each other, and we have to ensure that if one of the bot who has been working on a complex problem and it dies, what happens then? Who has the responsibility of bringing it up again, provisioning it, and things, maintaining the states of all the bots that are running, etc. So I've leveraged some of the concepts from SNMP to build that kind of a topology, right? And if whatever I'm speaking seems Greek or something, please stop me there. I'll try to make it as in a layman form as possible, because I'm now introducing some little bit networking concepts and things. Yeah, go ahead.
Actually, I'm sorry. I just wanted to curious. So I see you says up there as the bot always exists as a digital twin to validate outputs generated by the core bot. But a lot of times, I mean, so from what I can tell, you're essentially running a RAG, but then you're having the secondary bot digital twin step in to validate each input before it continues down the chain. But wouldn't that be better associated with something more akin to a bash script where it uses regex to perform, okay, is there code in this answer? Should we move forward on that kind of thing? Or is this a cost, cost is not a option? Cost is not a factor kind of development.
Yeah, so I think just to paraphrase what our friend just asked, so in this tenant, idea is that at any given point of time, at the minimum, very least, there will be at least two bots available, because one will be the real bot, like the one that is supposed to be working, and the other bot is the prime, like bot A dash, something like that, prime, which is the digital twin part of it, whose job is to make sure that A doesn't go haywire. So idea is that even if you use a RAG, even use anything, whatever you use it on A will also be used on the A dash as well. So it's like kind of a simulation of a exact replica of this person. All this replica is doing, it's like yin and yang, right? So while A focuses on maybe exploring, the A dash focuses on exploiting. So now you have explored, exploit, or you produce. This is just making sure the constraints are there, that it is within the constraints and it's not going completely all over the place. That's the duty of at least two. So that's the part. So at any given point of time, whenever you provision a new bot, it will provision at least two bots. One being your core bot, which is going to basically focus on your function that you're trying to optimize, and the other bot is the one that is going to keep this bot in check and just communicate with it. So for a real world perspective, the combination of these two bots will be considered as one bot itself. So from an external perspective, even the internal configuration is such there are two bots, but we will only consider one output of these bots. So think of it like this. So let's say I gave inventory optimization as a problem. Okay, that's the complex problem that I want to solve for, right? That I want to do inventory optimization. So I'm a retailer. I have a lot of produce that is coming in. I want to optimize my inventory. So this is the problem that is being given to the bot. What this bot would do, as a first step, is create a plan for how do we do inventory optimization. So it's like kind of like as a project manager, like a product manager or an architect of a project. What is the first thing that they do when the main project comes in? So I try to divide it into like small subtasks. Like, okay, how do I do inventory management? What are the requirements for that? What do I really require? What are the data that I require? Right? Who are the customers? What is the space? How does my fulfillment center look like, etc. So it will first do the work breakdown structure. So while the initial bot is doing the work breakdown structure, it will not going to generate the output as it is. The prime bot for it, which is a digital twin, would basically start validating the work breakdown structure. And both bots would be trained on different generative AI models. The idea here is that at least if one of them is doing wrong, the other one will not do exactly the same thing wrong. You see what I'm saying? Just to kind of make sense. And once both of them would have, yeah, go ahead. You had a question?
Oh, sorry, I just wanted to clarify. So you're saying the reason they won't come to the same conclusion is they're based on different models, or because they have different objectives? Because it sounded like you were saying one was acting as a critic, while one was acting as a generator
Right.
at first, but now you're talking about using different models. Is it what's driving the difference between?
Yeah. So good point. So basically, it is kind of a adversarial kind of a network. So if you think about neural networks, so I'm not going to go into too deep of those things, but think of it. So the first model is your prime model, which is tasked with basically doing the work, and the other model is to keeping it in the check. The idea here is that both of these models have to be trained on slightly different, like fundamental, like different LLMs. The reason being is if both of them are trained on the same thing, so what this model generates, most likely other model also think this is the right thing it generates. What is there to check anyway? So even though the objective function for both of them are different, as you rightly pointed out, which are different. The objective model for this model is to generate, and this model is to correct, right? So even though both the objectives are different, but since both are trained on a different like underlying like foundational LLM, idea is that if this guy misses something, this guy would produce something and things along those lines. That's the only objective. You could do it on the same model also, but these are some constraints that we have given that you are more likely to get a better optimal answer if you were to have this kind of a configuration. But nothing stops you to do it on a same model as well. But great point, actually. Any further questions before I move on? Yeah, go ahead.
Maybe you'll get to this, but have the outcomes of this solution been evaluated yet?
It's kind of mixed right now, so it is still under development. It's not fully like productionized or something. It's still in the, I would say, POC stage, like proof of concept still. It's very new. Like as I speak, it has never been presented to anyone. It has not even been published on our website. So this is the first time I'm basically, and the idea here is to also get feedback from people if you have done something like that, or you see there are implementations, or anyone wants to collaborate. If there are any investors who want to put money on this project, all are welcome. Okay, that's also one of the ideas. Any other questions? Yeah, go ahead.
Is there a, like the digital twin or the validating model that you are speaking about? Is there going to be only one model that will validate, or can we have multiple models?
Yeah. So that's
in that case.
Mhm.
One gentleman is pointing out that the multiple outputs are there, and you can make some sense out of it.
Excellent, very good point. So if you see, when I started, I said minimum 2 models, right? Which means you can have n, like you can have as much as well, but at the least it will not be 1 but 2 models. So you can have 10 models there who can validate it. It's the question about cost, right? So in a company, like you see, the other day, Sama was mentioning that they are trying to raise $7 trillion to build AI chips, right? $7 trillion. Think about it. All the magnificent seven total, I think, market cap itself is about 7 trillion, right? So he's saying you should give me this money so that I can make the. I wish I could say that as well, but the idea is the cost. Similarly, if you see whether it is Microsoft or whether it is Amazon or Meta, etc., lot of them have actually spent huge amount of money in the AI hardware, and most of it is going towards GPUs, right? Which are not even right suited for large language model. That's an irony. GPU started out with like graphic design models, like they're focused more on spatial or image processing kind of like use cases. But since there was nothing else available and Google took forever to come out with TPUs, and they are not even like TPUs are only available as a part of GCP. You can't like buy a TPU and like do it on your own, whereas you can do that with GPUs, right? So NVIDIA kept on going up and up and up. We'll see whether it continues that route or not by this end of this year. But the fact of the matter is, people just used whatever was available, and GPU was your like the when the gold rush happens, right? When the wild west people are doing, people who sell sickles make the money, and Nvidia was like that. Oh wow, everyone wants to do AI. Here is the GPU, take it, and their stock started rising, and people started using it. If you go in the internals, GPUs are not even fit for a large language model, because in large language models, you are not optimizing for accuracy. It is a language, so you're looking forward towards predicting what is most likely the next thing, which is like natural language processing. So a TPU will be a better fit there, but TPUs don't exist as hardware externally. So like, yeah, that's how it is. But that's industry, some other topic. But I'll focus back on this thing. Yeah, go ahead.
So if I may understand that we started the presentation with the problem that sometimes we are not getting the expected output. So that is because we are depending on one model like a monarchy, and we are trying to bring multiple models to sort of converting into democracy within the models and trying to make some better sense of the overall output. Is that what the direction like?
I like your, the way you described it. So I think the thing that he's proposing is that initially when I started out the presentation, I saw some of the cons of using LLMs and chat GPT and things along those lines. And one of the problems was that singleton model itself is not good fit for complex problems if you were to ask to solve for it. Am I moving towards a democratic model wherein I have now multiple models trying to solve for it? So in one sense, that's true. But in the other sense, what I'm proposing here is that no matter which model you use, one model will never be fit for solving it, because the problems are so complicated that they have to be divided into subtasks, and each task has to be done by basically each model. And based upon your problem, I don't know, you need 10 models or 50 models, or like how many bots. So I'm not using models. I'm going to say bots. And bots always exist in at least pair, as I said, right? So whenever I say bot, don't think it as one bot. At least it will be 2, and it could be 10 based upon like how much money do you want to spend and things like that, right? It's a optimization problem, because after a certain point of time, if you put more money into the problem, it's still not going to give you the better results. There is a like a infinite curve, right? So you always start hitting towards a level of like accuracy. After that, even if you put like more money, it is not going to move much needle. So you have to choose the optimal. So we said minimum is 2, maximum is based upon how much money you have and how much you are willing to basically put into it, right? That's how it is. Okay, so here is my ugly diagram. Sorry about it, but that's all I could come out with. So I think I have tried to explain it, but this pictorially it will become even more clear. So you see, that's the problem statement. That's where you start out with. So it's a complex problem, as I said, like route optimization. Even in network planning, like sometimes you have to do like fraud detection, right? And you have to use very complicated processes. Cybersecurity, in cybersecurity attacks happen, you have to detect that, things along those lines. So that's your problem statement, right? Independent of whatever problem statement can be applied. The first step is like your initial bot pair. So here it shows pair, but as I said, it could be minimum is 2, but it could be as you wish, right? But the minimum configuration is at least there will be 2 bots, bot 1 and 1. So you'll see I've shown there. I think as a pointer, I guess it has a pointer. Yes. So you see there is a like a prime. So every bot exists as a prime, like the real bot and the digital twin. That's the digital twin I was talking about. This is the real bot and this is its twin, and this, right? The idea here is, as one of the gentlemen pointed out there, that this is just a minimum configuration I'm showing. If you like as that gentleman mentioned, you could have 5 of them, 10 of them, like based upon how much money you have and how good you want it to be, right? So you have to choose the threshold as to like how much would be really valid here in our case. So first you do the work breakdown structure. That's like the top level problem divided into, let's say, 10 sub problems, right? I'm just giving this as an example. So that's So then the job of the first model will be to come out with the basically the work breakdown structure as to what will be your plan of action. That's the role of your first, right? After that, based upon whatever subtask it comes out, it basically distributes it to the other bot as it is shown here, right? Each of them can further do it. You're getting my point? So basically, once you have the per breakdown structure, first task comes in, it can be further broken down into other tasks, and it can continuously go in a like a hierarchy, as you see, right? It is showing out here. So idea is at a given point of time, when the whole network will be built, it may have hundreds of bots inside it, all over the place, right? So it becomes a very complicated structure. So now the magic of SNMP comes into the picture. So far we were only talking about one model, right? So one chat GPT model, or like even chat GPT has underlying multiple models inside it, right? It's not one model. Our proposal here is that even if other enterprises and companies, if they want to get into real complex problem solving, which is where the real money would be, not in just building like a question answer bot, which is what people have spent money in the past 2 years. The idea is we'll have to start getting into something more complicated like this. So idea here is as the network topology starts beginning to build, now you will have to start thinking about, okay, how will I provision bots? What if one of the bots dies out? What happens then? How do the bots communicate between each other? You see what I'm talking about? These are the problems when they only occur when you talk about like multiple bots. If you only have one, there is none of these problems exist. It all exists because you have now this kind of a topology. So the idea here is the first, the master bot, if I were to say that word, the role of that is to come out with the work breakdown structure and the entire network topology that would be required. Each of the further subsequent bots can create their own topologies as they go further, right? So, like for instance, bot number 2 can be the master bot here, and then they can spin off more kind of bots here based upon the work that they have. So it can keep going deeper as they want. Yeah, go ahead.
Are developers defining that topology, or are the bots defining their own topology, sub-topology dynamically?
Yeah, so since it is meant to be autonomous, idea is the developer gives the problem statement. Everything else has to be done by the bot. That's the whole autonomous idea, right? But it has a very big part. So it can generate a topology. Let's say it says we need 1 million bots. Would you run that topology? That's the question mark. So even though this is an autonomous model, but based upon the cost constraints you have and the kind of problem that you're solving, you should have a human in the loop. Meaning, a person who is an expert. As I said, this is not supposed to be done by layman developers like who doesn't even have any idea about network topology or generative AI, etc. To just okay, I have this thing. I work for Amazon, and Amazon says I want to make uh, 2% lift on Prime Day, and I have to recommend different products to different users. Let's solve this through this thing. It can still do it. Whether you will get a 2% lift or you will get a decline of 10%, we don't know, right? If it gives 2% lift, then that person becomes a director or VP in Amazon. But if it gets minus 10%, then they are fired basically. They are looking for unemployment, right? So a person who is using the system, even though it is autonomous, it will do it by automatically. It is expected that the person who is using it needs to validate when the initial work breakdown structure comes in that do you agree with this? Yay or nay kind of a thing, and then go further. So you can do it at each step. Once you become confident enough, there could be configurations here such that you can say, do you want it fully autonomous that you completely believe whatever it does and let it go, or you will have some constraints that if it goes beyond 10, ask the human in the loop before it goes further, or you can put a benchmark that if it uses too much CPU, then stop it here, ask a question, and then move forward. So you can put those kind of constraints there, right? So you can put physical constraints like money constraint, CPU constraint, or number of GPU constraints, or you can make it every step by step that every time it spins provisions new bots, it should ask a human whether it can do that or not. Did you have a question?
Yeah, actually, I'm sorry. I just wanted to ask. So I think a lot of what you are talking about is running this on with multiple different Chat GPT, multiple different bots, multiple different things. Even if you're using all the same prompt, how exactly is it breaking down deterministically to the point where you could collaborate the results of bot one on AWS and bot one on GCP and bot one on Azure or whatever Azure
Yeah.
uses?
Yeah.
But like it seems to me like there would need to be some kind of consensus between them two, so that between the layers, so that they can actually meaningfully transmit information back and forth. Otherwise you get like on this yak shaving quest where it goes, okay, the proper way to manage your memory is this, and it's like I wanted a CRUD app to assign phishing spots.
Right. No, this is a very good point. That's where SNMP comes into the picture. So that's where the simple network management protocol. So why I introduced those concepts when I was building onto this, because I knew this will become quite involved and we should know those concepts before we get into the deeper details here. The idea is each of these bots will basically be able to communicate. They'll give their health signal, saying that I'm up and running, this is the CPU I'm using, application performance management kind of a thing, right? So it will send those signals like throttling, CPU, all those kind of things. Plus, it will also talk about, so in the initial time, we talked about work breakdown structure, right? So let me take an example. I think it will become very clear for everyone. So let's say I want to do demand forecasting, okay? So I run I'm Amazon and I want to see how many people are going to visit my website tomorrow. Let's say this is what I want, right? I want to see the demand of people. Accordingly, so what do I need to do demand forecasting? So I need to know in the previous days how many people visited my website, what are the different pages that they basically clicked on my website, how many people did search, how many people did put the products in the cart, how many people abandoned their cart, how many people actually bought stuff on the cart, right? These are some of the things I would need to be able to understand what's my demand shaping so that I can forecast. And then I'll put all these signals to basically also take competition. Okay, what is Walmart selling? What is eBay selling? What is some other of these Nordstrom selling, etc. Right? And through all those signals, I can forecast. What is basically the demand going to come through, right? And to be able to do that, first I have to basically break down my structure. Okay, what is the basically my competition demand? What are the things that we have sold? All these points become your basically subtask. Like how do you get? So in an Amazon context, maybe there is a like a like a like a Spark query that basically brings in like for the last 20 days, get all the people who did this. For the last 30 days, get all the people who did this. They may be all each of them are different queries actually which pulls in that data, etc. Right? So when you basically have all of them together, all of these need to be combined, and each of those could be done by each of these different bots. That's what I'm trying to say. So work breakdown structure, each subtask is done by each bot. It can further subdivided further based upon as much as you want, and it goes all the way there. If you see the second last layer is the integrated results. So basically, results from each layer, basically when they basically come, they're stitched together because you need the result of the last 50 days, you need the result of where they clicked, etc., to come out with the final demand, right? So let's say the initial question was, what would be the demand for the next day? So that basically need to be stitched together in the end. And finally, that would be your solution. So that's what is presented here. So this is what next slide basically shows the system flow if you see. So when I talk about like first bot pair, so consider this pair as like, as I said, minimum pair is the minimum. Like at least you have to have two. Pair doesn't mean like only two. It could be more, right? But that's the minimum configuration. So that's the so you need the orchestration layer, you need provisioning, state management, etc. That's what I have taken from the SNMP protocol basically to manage all these things and spinning off the bots again and things along those lines. So pretty much, I think I'm almost done. I think this was my last slide if my memory serves me right. But I'm happy to answer any questions. Go ahead.
Yeah, I guess I'm trying to understand the first step. It seems like there's a lot of weight on the work breakdown structure. There's a lot of weight put on that first
Yeah,
step.
yeah.
And I noticed you have two bots there. And so I'm imagining they're figuring out the whole topology, as you said, to figure out everything else. So if you have multiple bots, how do you like combine that and integrate that if they have conflicting sort of like approaches to solving the problem? I'm having trouble sort of visualizing.
So I think got your question. So the question is that we have multiple bots out here, and each of them may have conflicting way of like solving for a problem. So how do we one combine the results whatever are coming, and how do we resolve conflicts if there are any between multiple bots? That's a very good question. Let's go back to the previous slide. This one. So if you see uh, the first, when we kickstart the process, when the initial provisioning of the bots is being done, the duty there is to come out with a work breakdown structure. So it's responsibility. It has to provision all the bots that it requires at that point of time, right? Same thing will be done by the bot number 2 as well. If it figures out that the subtask given to it, so basically they are not conflicting between themselves. So what bot 1 is doing is only for the task given to it. What bot 2 is giving is only to the subtask that it has. It doesn't go solve for something else. So let's say in the inventory management example that I was talking about earlier, let's say I wanted like what is the space in my fulfillment center. So let's say that task will be given to bot 2. Uh, the other space is what is the demand that is coming to my fulfillment center, that is given to bot number 3. So in one sense, each of them are focusing on an individual task. It's not conflicting, it's a mutually exclusive. What the previous bot is doing before that is making sure that individual bots that are being assigned the task are doing focused on only on that work. And there is a communication happening between all of them that it is working fine. So in case if let's say bot 2 dies while they're working upon it, it can be reprovisioned again and spin up again and things along those lines. It can be restarted. So those processes are running in the background. That's where I talked about the SNMP is coming. But in a fundamental sense, once let's say bot 2 basically completes, it will only complete basically if you see bot 2 when all the underlying bots under it basically will complete. So this will become the master bot for these. Until all of these complete, this process will not go down. You see what I'm saying? So it's like you're spinning off new processes. So this started, it created a very big, let's say, a forest underneath. Unless all of those have completed and they are mutually exclusive, they have nothing to do with this branch. They are completely independent. So once they complete their task, finally this bot will have the task to basically combine all the results, what I talked about here, integration of results. And then similar with this will combine the results, integrate it, and finally send it back to the previous. So first you basically explore. Explore is where you create all the provision, all the bots, activate those bots, they are doing their job, thing like that. And then exploit. Exploit part is they're completing their jobs, integrating. Finally, you get the solution out here. That's how it works. So they're all exclusive between each other. Yes, go ahead.
So sequentially, bot 1 alpha runs after bot 1.
Yes, because bot 1 has to first produce the thing what they want to do,
and then bot 1 alpha checks it.
Checks it.
So then mechanically, like going back to that fishing spot app, let's say bot K is fetching the lakes, bot K plus 1 is fetching the weather, bot N is fetching the fish, then bot ... is fetching the user base. Then they're all catting those results into integrated results. Then does bot number 1 have a continuous prompt to evaluate the integrated results to see if it's the solution, or is that like subcontracted to another prompt?
No, so basically, as I said, the bot 1's job is to first create the work breakdown structure, right? It will tell like how many bots are going to exist, and underneath the underlying bot's job is to focus on those basically the task given to it and work upon it. Once those work is done, etc., once those results are there, bot 1 will ensure that all the bots have completed their task and come out with results. That's how it is. Yeah, go ahead. Can you? I can't hear you.
How do you ensure that bot 1 and bot 1 prime create the same?
Bot 1 and bot 1 prime create what?
Like the same number of other bots.
Yeah. So basically, this is both in sequence actually. Bot 1 and bot 1 prime. So bot 1 first will generate a work breakdown structure. Let's say it says we create 10 subtasks, right? So bot 1 prime will look at those 10 and say, no, you shouldn't be creating 10, you should create 12. These are the results. So the final output from here will be 12 bots. Or it could say bot 1 says I want to create 8, and bot 1 prime will say no, 8 is not good, 5 should be good. And so basically the result of bot 1 will be basically validated by bot 1 prime, and then the final output will go out. That's how it is.
Who would create the final set of 5 then? Was it bot 1 or bot 1 prime?
So basically, each of these bots will solve for their subtask. Once it is there, it will go back to the previous one. It will create that. So So basically, hierarchy is being created, right, from the first all the way down to the forest. And as the leaf nodes basically start completing the task, it goes down up.
Sure, but for the digital twin, so for bot one prime, if it says in your case that it 5 is the right number, not 8, who then consolidates and recomputes the 5? Does it hand it back to bot one, or is bot one prime's job to create the 7?
Right. So there is a slight difference here. So unless both of them are in the sync, bot one and bot one prime are in the sync, it will not go further. So if bot one comes out says I want 10, and bot one prime says I only 5 is good, unless both of them are in the consensus that okay, I agree with this plan, they'll not go to the further step. So there is no concept of like it will first start 10 and then they'll like that. No. So basically, unless both of that's the beauty here, right? Unless this. So basically, here as a diagram, I'm showing them as two things. But for an external world, it is just one bot. You see what I'm saying? Internally, it is like digital twin kind of a concept. But so basically, it can only send one like result out. Like it cannot be 5 or 10. It won't do like that. Yeah.
And the result has to be the same. So if you had two different, if you're using OpenAI in one case and another, they ultimately have to come out with the same
Exactly.
result.
That's where the communication is there, because communication is the very critical part here, right? So all these guys have to talk to each other actually and build that consensus that okay, this is are going to be the step. So like how in ChatGPT like human and like bot is talking, right? Sometimes you give the answer, oh, I asked you to do 5 plus 5 is equal to 9, but you came out with 10. Fix your math. And ChatGPT responds like, okay, I'm sorry. Okay, yes, 5 plus 5 is 9. I'm just using this as an example, right? So these two guys also have to come to a consensus before they give the task to the underlying like processes and things like that.
Yeah, is there for like the planning or like in the topology, is there a particular foundation model that you found like produces better results? And then also, like, do you have any unique like foundation model pairs that you found for the bot and bot prime?
Oh, so this is like, as I said, this is still experimental point, like proof of concept. So focus more on the ideas I'm presenting here, but you got to do the experiment actually yourself to figure out. Maybe it will work well on Llama model, maybe it will not, because the whole I see when Hadoop was introduced, right? I'm just giving that as an example because I kind of worked intimately with that about a decade back when it was being coming out, right? The idea of Hadoop was not about whether it can give you the right results, etc. It was like you could use like commodity hardware to do parallel processing, and huge amount of workloads can be like shifted to Hadoop and work. Something similar concept is here, and it is improving the the functionality of a typical bot that exists today. Because a typical bot can never even imagine to do this kind of thing. A typical bot can still come out with a work breakdown structure. So like if you ask like a bot and say, I want to build a new website that will send offers to customers and blah blah blah. And if you write the prompts right, most likely it will come out with some like a plan, like okay, you have to do this, these are the structure and things like that. Maybe with ChatGPT 4o, etc., you can possibly come out with that. The problem is it will come out with that plan. Can it go through all the steps, like code everything that is there inside it and implement it and make sure it is validated, tested, and things like that? That's where it will fail. This is what it is solving for. So what we are saying is that maybe one bot will create a work breakdown structure, but maybe it is not correct structure. So you need a like a prime to make sure the structure that it has proposed is kind of okay. If it is okay, then have other bots start focusing on them, because as we know, complex programs are not atomic in nature, right? You need to divide them into sub problems, and each bot has to focus on their sub problem. But what is the sub problem for bot number one? It gives to bot number two, but bot number two finds out, well, this sub problem can be further subdivided into 10 sub problems, and that's what it goes and keeps going further. Our idea is, as we said, the pair that I represent here, the pair may not be just two bots together. It could be 4 bots, 5 bots, but one will be like your prime, which basically generates, and other are basically validating it and things like that. That's how basically the configuration is. Any other
Arvind, if maybe we can pen some questions for later.
Yeah,
I know
sure.
we're on the hour here, so
Sure.
did you have anything to wrap up and then?
I think I'm pretty much done here. Most likely, this is the last slide, I think. Yeah, these are some of the use cases, and I think some of the examples I already gave. So you can create like a test plan. You can do system design, network optimization, inventory planning, demand forecasting, blah, like all the complete. So the real meat of this solution is, yeah, go ahead.
Do you have any like demo kind of small, on an even empty Just to showcase
I-
how it's doing better than the existing LLM.
Yeah, as I said, it's still a POC, so we don't have any working demo or anything like that. We still need a lot of money to do all those things because it's just too costly to do. But the conceptual idea here is that if you fundamentally understand the concepts, and as I said, I'm not proposing something like it's kind of new, but I'm using something that already exists, like SNMP, foundation models already exist, communication already exists, frameworks already exist. We are bringing all of them together to introduce a new concept to solve for complicated problems. That's all it is basically showing. I think that's pretty much it. Yeah, that's my last slide. So thank you everyone. Happy to answer any questions.
Pitch your social media real quick. Go.
Yeah.
No. Introduce yourself for social media.
Sure, yeah. So hi, this is Arpit Gupta, one of the founders of Actionable Analytics. We are working on a new generative AI protocol that I introduced today here. Thank you very much. If you want to go to my YouTube channel, it is Real Talks One. It's not only about this; it has politics and economics and everything. I like those subjects as well. But happy to connect with all of you. Thank you.
All right.